Good afternoon, good evening, depending on the time and where you're watching from. I welcome you once again to our chemistry class, solution to 2025 WAEC past question, day 7. In this day 7, we'll be solving problems in WAEC 2025, starting from the number 37 down to 41, already written on the board. And question 37. Which of the following alkanols is tertiary? Which of the following alkanols is tertiary? Now, depending on the number of alkyl groups attached to the carbon atom bearing the functional group, that is the chiral carbon, alkanols can be divided into 3. We have primary alkanols, secondary alkanols, and tertiary alkanols. But depending on the number of what hydroxy group present per molecule of an alkanol, because alkanols can also be classified. Well, we have monohydric alkanols, dihydric alkanols, and trihydric alkanols. Now, on this, if you have an alkanol, a molecule with the chiral carbon, which is the carbon atom bearing the functional group OH, surrounded by 2 hydrogen and 1 alkyl group. R represents the alkyl group. This is a primary alkanol with degree what? 1. But if you have an alkanol with a carbon atom bearing the functional group surrounded by 1 hydrogen and 2 alkyl group, let's say this is R'1 and R'2. This is a secondary what? Alkanol. But if you have an alkanol with a carbon atom bearing the functional group, this is 2 degree, bearing the functional group with surrounded by 3 alkyl group. This is R'1, R'2, and R'3. This is a tertiary alkanol. So a primary alkanol has 2 hydrogen. The functional carbon atom bearing the functional group has 2 hydrogen and 1 alkyl group. In secondary alkanol, the carbon atom bearing the functional group, which we call chiral carbon or serocarbon, has 1 hydrogen and 2 alkyl groups. Alkyl group can be a methyl group, it can be a ethyl group, it can be a propyl group, and whatever. Then, in tertiary, the carbon atom bearing the functional group OH, which is a hydroxy group, has 3 alkyl groups. 3 alkyl groups, which are what? Made of 3 substituents, R'1, R'2, and R'2. Now, let's analyze the options. Option A, 2-methyl pentan 2-ol. 2-methyl pentan 2-ol. The 2-methyl pentan 2-ol, you just write the structure this way. Pentan is just 5 carbon atoms, that's base. If I have 1, 2, 3, then 4 and 5. 1, 2, 3, 4, 5. This is a skeletal structure of pentan. Then at carbon number 2, let's start from here. Okay. And the carbon must always be surrounded by 4 bonds because it's tetravalent electron and hydrogen 1 bond because it's monovalent or univalent. Okay. Then 2 methyl group is CH3. If you count from here, 1, 2, 3, 4, 5. That is pentan. Okay. At carbon number 2, there is an alkyl group which is a methyl. This is CH3. CH3, and at that same carbon there is an ol group OH, other one surrounded by hydrogen. Now, if you check, this is carbon number 2 is the chiral carbon, which is the carbon atom bearing the functional group, and this carbon atom bearing the functional group has this is a substituent which is a methyl group. This is another substituent which is also electric with CH3. This is 1, 2, 3, and C. Then this is another substituent which is what? OH. Here, and all here is 1, 2, 3. This is a propyl group. So the carbon atom bearing the functional group has 3 of alkyl. Look at it from here. This is R prime, this one, and this, and this. Of course, even if the functional group OH goes here becomes another R prime 1, prime 2, and prime 3. 1, 2, 3. This is 1, 2, 3. Of course, this is a tertiary alkanol and seems to be the right answer. If you check the second option, 2-methyl pentan 1-or 2-methyl, still that 2-methyl, but the all group is now attached as what? Carbon number what? 1. Here or here. Carbon number 1 and here will be hydrogen. You see that the carbon atom bearing the functional group has 2 hydrogen, 1, 2, and what? 1 alkyl group. So this is the primary what? Alkanol. 2-methyl pentan 1-or is a primary alkanol. What about pentan 3-or? This pentan 3-or. Then at carbon number, this is 1, 2, 3. At 3, this is OH. 1, 2, 3. At carbon number 3, OH. Other ones surrounded by. So the carbon atom bearing the functional group has, this is an alkyl group, which is an ethyl, and this is another alkyl group, which is an ethyl also, and 1 hydrogen. It has 2 alkyl group, 1 hydrogen. 2 alkyl group, 1 hydrogen, which is a secondary water. This is 2, degree 2. So option C is a secondary alkanol. What about option D? Pentan 2-or. At carbon number 2, there is an OR group. Here. Pentan 2-or. And this is the carbon atom bearing the functional group. It has 1 hydrogen and 2 alkyl groups. 1 hydrogen and 2 alkyl groups, which is also what the secondary water alkanol. So the only one that is tertiary is option A. Option A is a tertiary, which the carbon atom bearing the functional group has 1 hydrogen and what? 3 alkyl groups. Of course, the 3 alkyl groups 1 to 3. So the next one is already OH. So correct option is A. Then question 38. Which of the following elements is commercially obtained by the electrolysis of each fused salt? Which of the following elements is commercially obtained by the electrolysis of each fused salt? Now, you must know the electrochemical series concerning the electropositivity. We use this, that King Nathan can manage all zones since all zones freely since probably he could hand age again. Now, he could hand age, that is age. It's probably that's less. He could hand age, and finally, again, that is age. Age. This is 2 plus here. See. Now, the first 2 is the most electropositive. Of course, reactivity is decreasing down the group. The most reactive metal is potassium followed by sodium. Okay, it is most reactive. Then hydrogen. You know hydrogen here, this is moderately reactive. This is most reactive. Most reactive. these reactive metals. Now, these first two, the most reactive, of course, they are obtained by electrolysis of their fused what? Hydroxide. Sodium and potassium are obtained by electrolysis of their fused hydroxide or fused chloride, or majorly calcium and magnesium. They are obtained by electrolysis of what? Their fused chloride. Aluminium, as electrolysis of its purified or majorly or bauxite. Then down here by what? Reduction of their or can be the oxide from their sulfide by using a strong, maybe reducing agent like carbon or carbon dioxide. Then the question is, which of the following is commercially obtained by electrolysis of the fused what? You have silver, no, copper, no, which is below 10. So the correct option is was sodium, which is what electrolysis of their fused what? Salt. The fused salts can be what? They are chloride or they are what? Hydroxide. So the correct option is sodium. Question 39. The luxure of a metal is due to its dash high density, B refractive index, C chemical inertness, and D free electrons. What is luxure? Almost all metals have a physical property known as what? Metallic luster. That's the ability of a metal to shine or sparkle when cut or what? Polished. The ability of a metal to shine or sparkle when cut or polished. And what is responsible for their luster is either high refractive index and dispersion power. Any metal, all metal have high refractive index and high dispersion power, and that is why they can shine or sparkle when you cut them or you polish them. So the correct option is B, refractive index, not chemical inertness, not free electrons. Question 40. Exothermic reactions take place when energy given out in making bonds is dashed less than energy taken in for breaking bonds, B greater than energy taken in for breaking bonds, C equal to the energy taken in for breaking bonds, D remain the same as the energy taken in. Okay, now recall that in exothermic reaction, delta H, which is the change in free energy loss for the enthalpy of reaction, is negative. Why? Because heat is what? Given out. It's negative. Why? Because heat is what? Given out. And for delta H to be negative, now from the expression, that change in what? Enthalpy of the reaction will be equal to heat of the product minus heat of the reactant. So from this expression, for delta H to be positive, it means that, for delta H to be negative, means that the heat of the product must be what? Must be less than the heat of the reactant, or that the heat of the reactant is greater than the heat of the product. The heat of the product, that is what? In a given chemical equation, at the reactant site, bonds are what? Broken. Bonds are broken. Then at the product site, new bonds are what? Formed. So for a given reaction, bonds needs to be what? Broken at the right hand side prior to what? New bond formation at the product side. So the energy was required for the bond to broken at the reactant side. Now that's the heat of the product. That is the bond formation and heat of the reaction. So the question says exothermic reaction takes place when energy given out in making bonds, that is at the product side. That's energy given out in making bonds, that is heat of the product, is less than the energy taken in for what? Breaking bonds. The energy taken in for breaking bonds. So here the correct option is, since the heat of the product Hp, that's the energy given out in making bond, is less than the energy taken in for what breaking bonds. Since Hp is less than what HR, so the correct option is greater than no, not greater than energy taken in for breaking bond, equal, no, not equal, then remain the same. So the correct option is A. So the energy given out in making bonds is less than the energy taken in for breaking bonds during exothermic reaction. But in endothermic reaction, the reverse is the case, which means that the heat of the product is greater than the heat of the reactant. It means that the energy taken in for breaking bonds, of course, here will be what? I mean, the energy given out in making bonds will be greater than the energy taken in for breaking bonds. That is for endothermic reaction, because heat is given out. So in this, but in endothermic reaction, heat is taken in from the surroundings into the reaction system, and that is why the heat of the product will be greater than the heat of the reactants. Okay, question number 41. Which of the following metals would not release hydrogen when reacted with dilute hydrochloric acid? When reacted with what? Dilute hydrochloric acid. Symbol to this electropositivity. Now let's do it again. We have King, Nathan, can manage all zones freely, since probably he could and age, that is 2 plus mercury. Again, in this electropositivity, the most reactive metals, this is moderately reactive. Now, any metal that is below hydrogen in the electrochemical states cannot displace hydrogen in a solution of acid or water. Look at this metal like copper, Cu, Hg, that is mercury, hydrogen, then argentum, that is silver, Ag, and what gold, Au, can never displace what? Hydrogen in a solution of acid or water, because hydrogen is more reactive. See this, the reactivity, most reactive, moderately reactive, and less reactive. So the reactivity is what? Decreasing down, which means that sodium, potassium is more reactive than sodium, and what? Sodium is more reactive than what? Potassium. The same way here, lead is more reactive than hydrogen, and hydrogen is more reactive than what? Copper. So since hydrogen is more reactive than copper, so copper and all other metal that is below it in this electrochemical series or reactivity series can never displace hydrogen in it. So if you have copper here, Cu, like this Ag, silver here, plus HCl in aqueous. All metal is in a solid state at room temperature except steel like mercury and bismuth. So this silver, because hydrogen is more reactive and placed high in the electrochemical series compared to this, it can never displace. So the correct answer to this is no reaction. No reaction. So if you take carbon is high than hydrogen in the electrochemical series, I can displace it. Look at iron, Fe, it can displace it. Then zinc, this is zinc, is high than hydrogen, but silver, which is Ag, is lower in the electrochemical series than hydrogen and can never be. So the correct option here is option B. Option B. So any metal that is lower in the electrochemical series than hydrogen can never displace hydrogen in a solution of what? Acid or water. Okay, so in our this 8, we'll be starting from 42. Do remember to like, share, and comment, and follow Superstar School of Science for more of chemistry lessons. Do you have a wonderful day? See you in our day 8 to solution to 2025 WAEC past question in chemistry. Bye. God bless.